Okay, so in last night's type 3, I did ask you guys to skip a couple of questions for a reason, because this term called union is involved. Let's discuss what that means. I had just asked you what union meant, and many people said putting things together, which is correct. So union, a notation that allows us to account for holes or gaps in the domain and range of a function. Well, let's say relation, because some of those are not functions. So let me start off with a word example. If I told you x can be any number except, give me a negative small number. Negative 1, and give me a positive value between 1 and 20. 12, I heard. Okay, so x can be any number except negative 1 and 12. And so here we'd be talking about the domain or the range. Domain, because we're talking about x values. Good. The way that I would represent that is strictly with interval notation. We do not use set notation for this. So this is strictly going to be a combination of brackets and parentheses. So when you see these two numbers and mentally you are taking them out of the number line, literally think left to right. I would be saying my domain is negative infinity to what? Negative 1. Would this get a bracket or a parenthesis? It can't be negative 1, so bracket or parenthesis. Parenthesis. And here's the key symbol. Union. That's what that U means. Union. Where am I going to pick up my domain from? Nope, careful. Think of a number line. What comes after negative 1? 0. So if I start at 12, I'm jumping all the way to 12. So we're actually going to pick up right where we left off. Still with a parenthesis. So you can literally imagine that this union symbol represents that hole at negative 1. Can't be at negative 1. But I can be from negative 1 to where? 12. What am I going to have to write again? Union, U, good. And then what's the remainder of this going to look like? 12 to infinity. Kind of cool, right? So this means union. And coming full circle to what you said about union means grouping things together, how many pieces of interval notation are you grouping together here? 3. So that mental picture of what you said union means does apply to this. So now let's look how this would apply to number 1 on the type 3. With what we just talked about in mind, we definitely know, don't write this, we definitely know it's not going to be this. My domain can't be that, because how many holes are in the middle? Careful. Is this in the middle? No, this is at the end. Good. So we have to account for 2 values that it can't be. Can you use the notes you just took and try? Try writing the domain. Ask yourself, what value can it not be? I'm going to do it with you in a second, but I genuinely want you to try first. Look at where the holes are. Where are those on the x-axis? How do you exclude those values from the domain? Jasmine, try. Keep writing something more. Look at the notes you just took. It's basically going to be the same setup, except we're excluding 2 different x values. What are the x values that are being excluded here? -2 and 2. Okay, so you had a chance to try. Now let's see if we can do this together. For anyone who is struggling, I literally take a look at the screen, and I don't mean struggling, I mean you haven't gotten it yet. You want to visualize this as 3 pieces. Here's one piece. So cover this up with your finger. I only want you to see this segment. Cover it up, cover it up, cover it up. I'll wait. Cover up these 2 pieces right here. Just allow yourself to see this. If I asked you what the domain from here to here is, what would you tell me? -4 to -2. That's my first piece. Union. Now cover up this piece and just see the middle. So that might take 2 fingers. Do it. Cover it up. Cover up the left piece and the right piece. Just allow yourself to see the middle. What would the domain of this middle piece be? There's my next chunk. -2 to 2. And now cover up these left 2 sections. Just allow yourself to see this ray right here. What would my last part of this be? Very good. So that is a concrete way to kind of mentally take this step by step. See it in pieces. So what this hole right here is represented algebraically. This means exclude -2. That's what that means. It means that I have a hole at -2. Right here, exclude 2. Now for the range, can I say -4 to infinity? Interesting question. Well, I know my range is going to start at -4. Can we all agree on that? Okay. Now I'm going. I see these open circles right here, but we see that we have points right here. Like, what is this ordered pair? 0, 1. So because this segment does exist, it kind of fills in the holes. Let me say that again. Because this segment exists here, and for example, you were able to tell me that this is 0, 1, this is 1, 1, this is -1, 1, that 1 as a y value is part of my possible y values. So it fills in the holes to the left and right if you looking at your values. So these 2 holes did affect my domain. They do not affect my range. So for the range, this will be -4. Is it -4? Ooh, okay. So let me just finish the top. The top is 1. What's wrong about what I just wrote? Cassidy has an idea, but I'm going to wait. Think. What do you think? Perfection. This arrow keeps going forever and ever and ever and ever. Which means I should not have -4 to 1. It should be what? Very good. -infinity to 1. Awesome. And we're going to keep practicing with union, okay? And remember, this will be available to you online, so you can re-listen to the definition we just went through and then re-listen to this explanation. Does number 2 have any need for union? No. And from this point forward, the expectation is you are equally comfortable with set and interval. So all of the answers I'll put up in interval. If you have a question on what the set notation would look like, just let me know. Okay? For interval notation, what is my domain? -4 to infinity. Does this get a bracket or a parenthesis? Parenthesis over here? Parenthesis. Good. That hole means I cannot equal -4. And when I come in from the right side, I hit an arrow, positive infinity. Great. My range? 1, bracket or parenthesis. Good. And the right side? Careful. Remember, arrows keep going. So yes, it looks like it could be 3, but this arrow keeps going and going and going. So when in doubt, extend the arrow. So as we're working, make sure you're actually marking correct what's correct. If you did not practice set notation, practice it off to the side. Good job. Number 3. Am I going to need union? Yes. So let's talk domain first. What's the domain for number 3? Yes. So domain, if I look, I'm just looking at x values. Don't look up and down. Just looking at x values, I'm totally good. Coming in from the left and the right, all of my values exist. Where is union going to be necessary? In the range. So now, visually, you're going to be looking up and down. So when I come in from the bottom, what's my first y value? But it's just always 1 here, yes? So we're going to indicate that with a bracket 1. That's it. It's only 1. It's a horizontal line. Union, what other y value? Very good. And 3 will go in brackets. As funky as that looks, if we think about it, it really does make sense, because any ordered pair on this piece of the line is always going to have what as a y value? 1. 1. And this, any point on this ray over here is always going to have what as a y value? 3. So for this entire function, the only possible y values are 1 and 3. And we're done. Winter, if that's in your eyes, someone can pull the string on the far right and it'll close that. Can someone on the side help them out? Okay. Number 4, domain. Good job. Range. There you go. 0, infinity. So when I come in from the bottom, and I can understand when people were saying what they were saying, I could see how they would read that. But remember, if this is my pencil, right, and I'm coming in from the bottom, I stop when I hit the graph. For the range, the question has to be, where are you on the y-axis? On the y-axis, where are you? 0. If you're pulling this number over here, that's a location on the x-axis. I need where am I on the y-axis? 0. And then when I come in from the top, I hit an arrow. So anyone who said